The concepts of creating cheap electricity is so straightforward when you're trying to use air duct. All you're doing is just imagine that you have an air duct with a radius of 10 feet. And a portion of it is a section that is 30 feet radius. That section is darker color, either black, dark green, dark blue. But what happens is that because of the sun, that part gets heated up more than the rest. And then the air inside of it wants to expand. If the air is heated up, let's say about 40 degrees Fahrenheit, because of that, then it expands about 6%. Well, then it wants to move. That air ends up having some velocity, let's say about 15 or 20 miles per hour. Not much velocity at all. But when it gets to the 10 feet radius section, then suddenly the velocity of it goes up to 90 miles, 100 miles per hour. And if the end of the air duct is about 500 feet elevation compared to entrance, then also air expands another 2%. So now you have a 8% expanding and creating velocity to the air, and that is the basis of creating wind energy by simply having an air duct. You're using the sun. If you like, you can use solar panels so that the section that's supposed to be heated up can be smaller or smaller radius. But this way, you can control it any way you want. And this kind of science has been around for a long time. For the last, the modern version of it about the last 50 years or so, when they talk about computational fluid dynamics, those consultants, this is what they do, that they figure out that what lengths of what radius with what air velocity, later on when we change the radius, how much the new velocity will be. And that has different restrictions, constraints like the friction, the lengths, the total lengths of the air duct and so forth. But at the end, they will tell us exactly what lengths of air duct we need in order to produce the best, the optimum level of velocity for in order to generate electricity. So in order to generate electricity, we can go and actually help the existing wind turbines. That's one way. We can actually have an electric generator inside of it. But except this, we can do many other things, like you want to get rid of pollution. Fine. Just get some filters inside of it. So in terms of being practical, it's really practical. But we can have different purposes for it. The amount that I came up with is that for a $50 million project, 20 millions of it will be for about roughly 200 long air ducts, and those will be actually doing the things that are environmental in terms of helping with whatever cause that we have. The other 30 million will be on short air ducts that have electric generators inside them, or they are in another site, and because of that, they are helping existing wind turbines to produce more electricity. So that way, we skip the idea of even getting those extra generators. In terms of the world, imagine that there's about 100 projects of those 50 millions that are urgent. But in terms of what the world can actually handle and what the world actually needs is about 2,400 of them. But that's why I'm focusing on the first 100, depending on the country, depending on who wants to actually do it, and that becomes $5 billion. But each individual or each group will be interested in a portion of it, and that's fine too.